Okay, in example number 10, we want to find a break-even point and the profit function using substitution. So the question for example number 10, the break-even point is the following. So we're looking for the break-even point, and the break-even point is where they intersect. So what we're doing is we're looking for the solution to the system of equations. Now, we're given the cost function, c of x, which is equal to 0.85x plus 35,000. And we're also given the revenue function, r of x, which is equal to 1.55x. And what we want to do is we want to find the break-even point and then the profit function. So the first thing we want to do is we're going to write the systems of equations using y to replace the function notation. So instead of writing c of x, we're going to say y is going to equal 0.85x plus 35,000. And then the revenue function, r of x, we're going to say now is y, which is equal to 1.55x. And then what we're going to do is we're going to substitute the expression 0.85x plus 35,000 from the first equation into the second equation and solve for x. So in the first equation, we know this is what y equals. So we're going to substitute y to be that equation. And so now what we end up getting is an entire equation that only has x in them, and so we can solve for it. So the first thing we're going to do is we're going to subtract 0.85x to both sides. And when we do that, we get 0.7x, which is equal to 35,000. And then when we divide both sides by 0.7, we get x, which is equal to 5,000. And now once we get that answer, we can then substitute x, which is 50,000, into either the cost function or the revenue function. So the easiest one would be equation number 2. So y is going to equal 1.55x, and then we're going to plug 5,000 in for x, and we get y, which is equal to 1.55 times 50,000, which is equal to 77,500. So therefore, the break-even point is then the following, 50,000, 77,500. So if we take a look back up here, okay, again, this is where the break-even point would be, is where they intersect. Now, the next part is that we want to be able to find the profit function. So the profit function is found by using the formula p of x, which is equal to r of x minus c of x. So we know that r of x from the beginning part of the question is 1.55x minus the cost function, which is 0.85x plus 35,000. So what we're going to do is we're going to distribute this minus sign to get 1.55x minus 0.85x plus 35,000. And then when we combine those terms, we end up getting 0.7x plus 35,000. So the profit function is p of x, which is equal to 0.7x minus 35,000. So the cost to produce 50,000 units is $77,500. And the revenue from the sales of 50,000 units is also $77,500. So to make a profit, the business must produce and sell more than 50,000 units. Now, that's what we see in figure number 11. So here is our break-even point. Okay. And so we can then see that from the graph in figure 12, that the profit function has a negative value until x is equal to 50,000 when the graph crosses the x-axis. Then the graph emerges into positive y values and continues on this path as the profit function is a straight line. This illustrates that the break-even point for businesses occurs when the profit function is 0. And then the area to the left of the break-even point represents operating at a loss.